welcome to this video on how to solve two-step equations using algebra tiles. Now, before we jump into exactly how to do this using algebra tiles, I want to explain for a moment the importance of keeping an equation true. Now, if you look at this mat, there's an equal sign in the middle, there's a left side and a right side. Right down here, you'll see it says 0 equals 0. Now, is 0 equals 0 true? Of course it's true. It's a true statement, mathematical statement, that is. Now, if I drag this square here, this square represents 1 unit. Is the statement down here still true? It says 1 equals 0. That is not a true statement. 1 does not equal 0. What would we have to do to make this statement true again? Of course, we'll have to drag another 1 on the other side. Now, is the statement true? 1 equals 1. It is true. Now, if I add another tile here, now is the statement true? It is no longer true. 2 does not equal 1. What do we have to do to make the statement true? Of course, add another tile to the other side. Now the statement is true again. 2 equals 2. We can go on and do the same thing. Anytime I add another tile, I'm going to make the statement false. 3 does not equal 2. If we want to make it true, we have to, whatever we did to one side, we have to do to the other side to keep the equation true. If we do not do the same thing to both sides, the equation will not be a true statement. Remember that as we're solving equations, that in order to keep an equation true or balanced, we have to do the same operation to both sides. Okay? Now, these tiles here, the green ones, the X tiles, are unknown. X is like a question mark. We don't know what the value is. Right now, it says X equals 0 because nothing is on the other side of the mat. If I put tiles on that side, notice the bottom will reveal what X equals. X equals 2. I'm going to make a two-step equation and model it. So now let's do this one. Okay, so now we have 2x plus 3 equals 5. Notice that our equation is, our statement is down here, but here we have algebra tiles that represent that equation. So 2x's plus 3 units equals 5 units. Now, when we're using algebra tiles, we want to get this green tile, the X tile, by itself because we want to figure out what X equals since it's unknown. The way we do that is by manipulating or doing something to both sides of the equation, all the while keeping it balanced or true. In order to get X by itself, I need to get these yellow ones to cancel out. The only way to get these yellow tiles to cancel out is to make a zero pair. A zero pair is a pair of tiles that equal 0. So notice I have these negative red tiles. A positive 1 and a negative 1 together equals 0. Think about it. 1 minus 1 equals 0. That's called a zero pair. So I'm going to make 0 pairs for each of the yellow tiles so that they all cancel out because after all, we want to try to get X by itself. But remember, we always have to keep an equation balanced or true. So whatever we did to one side of the equation, we have to do the same thing to the other side of the equation. So I added 3 negative tiles to that side, so I have to add 3 negative tiles to the other side of the equal sign. Now our equation is balanced. Now, if you grab a red tile or a yellow tile and put it on top of each other, they disappear. Since they're a zero pair, they equal 0, therefore they disappear. So let's go ahead and make these 0 pairs disappear. Perfect. So now we're left with 2x equals 2. If we separate these into groups, we can figure out what x equals. One of these x tiles, the green tile, equals 1. X equals 1. So we found our answer, x equals 1. And as you can tell right here in this equation, this means 2 times something equals 2. If you divide both sides by 2, we can clearly see as well that x equals 1.